Okay, so I want to try graphing this secant from the example handout that I gave you way back at the beginning of the unit. So in this one, secant is 1 over cosine, so really this graph is going to look a lot like cosine of pi over 2 times x minus 3, just sort of flipped inside out the way that you flip cosine inside out to get the secant graph. So we'll just go through those 4 main features of all the trig functions. So the vertical stretch, stretch, is really just 1. There's no number in front here that multiplies the trig functions, so you assume it's 1. The period, now the period of regular secant is just the period of cosine, so that's 2 pi. So this one, b is pi over 2. So I'm going to calculate my period the same way that I did with cosine and sine, which is 2 pi divided by b. And so that's the same thing as 2 pi times the reciprocal of the denominator. So I'm going to get 4 out of that. So period is 4. Vertical shift, there's nothing added on at the end here, so that's like plus 0. And then the horizontal shift, or phase shift, would be 3 units to the right. So now we got that, and then it's just a matter of actually trying to get this thing graphed properly. So let me get some axes down here. And I'm going to start. Now, I usually don't think great in terms of secant directly until I have a graph of cosine to look at. So I'm going to just quickly graph cosine here. And then secant is that version of cosine but flipped inside out, so I'll do that in red. Whoops. So let's get the asymptotes down first. And if you have the graph of secant and cosecant memorized, you don't have to bother drawing out the cosine and sine graph. I just do this because I can't think that way. So, okay, so we got this. Normally, it's going to go from 0 here. This would happen at pi. This would happen at 2 pi. Oh, no, I'm messing that up. Sorry. This would happen at pi over 2. The low point would happen at pi. This would be at 3 pi over 2. And the high point would happen again at 2 pi. So let's see. Oh, and then to finish off our graph of secant here, this is before we've done any translations. It'll shoot down like this and up like that. So now I've got a decent amount of stuff to look at here. Now, normally this low point's at -1 and the high point's at 1. And I didn't stretch it vertically, so it's still -1 and 1. And then I didn't shift it up or down, so it stays there. The period, though, is 4. So instead of going from 0 to 2 pi, it's going to go 0 to 4. But then I move everything 3 units right, so really it's going to go from 3 to 7 in this range where I was before. So what I'm going to do is, I know that this point right here is really going to be 3 comma 1. And this point right here is really going to be 7 comma 1. And this point down at the bottom is really going to be right in between 3 and 7, so 5 comma -1. And so let me get rid of this pi over 2 stuff because that's going to get confusing. Whoops, didn't want to erase all that yet. Where's the undo? I don't know where the undo button went. Oh, there it is. Okay. So, sorry. Let me get rid of this again. Okay. And let's see. This point right here is right in the middle of 3 and 5. So that's going to be 4 comma 0. And then this will be 6 comma 0. Oh, that doesn't matter. That's not even on the red graph. So let me do this. Oh, well, this will be at x equals 4. This will be x equals 5, 6. Yeah, okay. So what I'm able to do that you're not is I can easily erase my original axes and that graph And then all I need to do is reposition the axes in the right place. So if you notice, it goes 7, 5, 3, 2. So this is going to be 1. And then, so right here, this is 1 comma negative 1. This would have been x equals 2, so this lies right on the x-axis, or on the y-axis here. And then my x-axis just goes straight down the middle. So that's what your graph should actually look like when you're all said and done. If you ended up figuring out this point for some reason, it's negative 1, 1. Okay.